Robots working in messy, dynamic spaces, streets, job sites, must be able to interpret their surroundings. Semantic segmentation delivers that, as it assigns meaning to every pixel and point. But creating dense labels on real RGB and LiDAR data is costly, and models trained on synthetic data face a synthetic-to-real gap due to shifts in lighting, texture, and sensor patterns. Active domain adaptation helps by allowing the model to learn from a subset of a real-world dataset according to the model's own uncertainty. But uncertainty alone can overlook overconfident, rare, or atypical cases. We introduce RAFT, Robust Augmentation of Features, for both RGB and LiDAR segmentation. RAFT enlarges each class's learned distribution in two ways, so the limited label budget can target what augmentation can't cover. First, hyperbolic active learning. We score pixels/voxels by combining prediction uncertainty with a hyperbolic radius signal that captures data scarcity, steering annotations to the most informative examples across sensors. Second, hyperbolic feature augmentation. For each class, we learn a wrapped normal distribution in hyperbolic space and sample along geodesics to create class-faithful features just beyond the current boundary. No extra labels required. Third, domain mixing. We form hybrid inputs by blending confident target regions with source data under pseudo-labels, nudging the encoder to align source and target domains without supervision. Together, mixing aligns inputs, HFA broadens per-class coverage, and the selector spends labels on the true outliers. We demonstrate RAFT on real-world data collected with a Unitree Go-To EDU platform, showing consistent gains over active learning-only baselines. Here we are displaying the Go-To robot alongside RGB and LiDAR segmentations of its surrounding environment. Here the annotator-trained MinkNet fails to detect the plants between the building and cars, while the RAFT MinkNet classifies it correctly as vegetation. While the RAFT-trained Deep Lab is imperfect with curbs, it identifies the grass within, while the Halo Deep Lab struggles,